Cornell's Alpha CubeSat is a light sail carrying one-unit cube-shaped satellite and a stepping stone to our nearest star system. Its technological innovations paved the way for future light sails to reach 1/5 the speed of light, 400 times faster than any current spacecraft.
Light sails, as the name suggests, are a lot like boat sails. But instead of being pushed by wind, light sails are pushed by the actual photons that strike them. JAXA's Icaros in 2010 made this a reality, and the Planetary Society's Light Sail 2 demonstrated sailing with sunlight, or solar sailing, while in low Earth orbit.
Solar sailing can propel light sails toward other planets, but if we want to get to Alpha Centauri, we're going to need something stronger, like laser power, and a lot more experimenting first. One of Alpha's goals is to help test these new technologies.
Alpha CubeSat's light sail design is different from its predecessors. It's a lot smaller, first of all, but more importantly, Alpha's sail has a low mass per area. The lower this mass per area, the faster we can accelerate the sail, and the shorter our travel time. Alpha has a pretty similar ratio to previous sails, making it just as efficient for a lower cost.
Alpha's palm-sized computers, in the form of ChipSats, are what allow the light sail to be so small. These circuit boards fit in the palm of your hand, but still contain all the necessary radio communications, sensors, and power systems. Most previous sails have been attached to spacecraft with larger computers, but ChipSats allow Alpha to completely disconnect from the satellite and become the first ever free-flying light sail in space.
Alpha's light sail is also different in that the material isn't just reflective, it's retroreflective, which is the same effect you see in cat's eyes and shining signs at night. If something is retroreflective, it doesn't just scatter light back at different angles. It sends it directly back on the same path it followed to hit the material. This keeps the light sail moving in the right direction and causes the photons to exert a larger force on the sail. Alpha CubeSat will hopefully launch in late 2022 or early 2023, then deploy from the International Space Station. Once the CubeSat deploys, we'll enter a 24-hour waiting period before we release the light sail, just to make sure none of our components hit the ISS. During this time, the CubeSat will stabilize and align itself with the Earth's magnetic field to allow easy contact and prevent the light sail itself from tumbling out randomly. Our stabilization technique is another innovation. We'll accomplish this using only magnetorquers, coils that produce their own magnetic field, which then interacts with Earth's. Because it's so small, Alpha's light sail doesn't need any motors to unfold. An origami folding technique and a shape memory alloy frame do the trick. The compartment storing the sail takes up half the 3D printed body, another of Alpha's cost-efficient innovations. The rest of the satellite is devoted to the CubeSat's own electronics. We use low-cost, easy-to-obtain components, such as the Rock Block, a modem making its debut CubeSat mission with Alpha. The Rock Block allows us to communicate with the satellite simply over a website. When we send our command to deploy, a fishing line holding back a spring-loaded latch is cut, and the door beneath one of 6 solar panels opens, releasing the sail. The CubeSat will take a picture to make sure the light sail deployed properly, and then the rest of the sailing mission is up to the ChipSats.
Although Alpha will stay just above Earth, its successors may be speeding through other star systems. Taking after the Pioneer plaques and Voyager golden records, Alpha aims to demonstrate a new medium for interstellar messages in the form of holograms. On the CubeSat solar panels, we'll be placing holographic art created by C. Banks, who has decades of experience with holographic messages. Alpha will only have one picture per panel, but due to the parallax nature of holograms, how you can move your head from side to side and see different images, it's possible to include much more information in a holographic message than any metal plaque before it. These will be the first pieces of holographic art in space, hopefully paving the way for many more. My favorite quote from Carl Sagan is, "For small creatures such as we, the vastness is bearable only through love." Projects like Alpha are products of that love, for exploration and scientific knowledge, but also through its holograms of humankind and animal life, a love for our home. Every mission in spaceflight, successful or not, is a chance to send a little part of ourselves out there. CubeSats, light sails, holographic greetings to the stars. All of these are stepping stones in the grand scale of human exploration, from our solar system to the nearest stars and beyond. Here at Alpha, we're honored to be a part of that.